In this video, I want to talk about some of the limitations that exist with JavaScript libraries and Ethereum APIs such as Web3.js and Ethers.js. Those are the two most popular ones, but there are similar ones. Common for these type of tools is that they will help you from your front end or back end to communicate with the Ethereum blockchain. It provides an API so that you can interact with the Ethereum blockchain from, for example, your web browser, so that you can retrieve data from smart contracts, you can send transactions to smart contracts, you can get information such as events, and you can get transactions from that API. And if you are a dApp Solidity developer, you have used these tools, and I use them all the time, and they're very powerful, and they have been improving a lot over the years. But in this video, I want to talk about the limitations that those tools provide and the situations where you will need more tools than those in order to build more powerful and more usable dApps. And in the end, I will also share the tools that you will need if you want to get past this limit, meaning what kind of tools you need in order to really get all of the functionality that you can from a dApp and get all of the power from the Ethereum blockchain. So let's take an example. Here I have the popular tool Syrian. You can find this at syrian.io. And this is just a random address that I've entered here into the tool. So it's not my address. But Syrian is like a portfolio manager. You can see all of the assets that a specific address has, the current value, and so on. So they just you just input an address here, and when you go to it the first time, it will just pick the address from your MetaMask. And that's quite cool. So, you don't need any sign up. It just integrates directly with your wallet and you get all of the assets. But how do they actually get all of the coins that you own? How does it know all of the different tokens that you own? Because a lot of people think that just because you have MetaMask and MetaMask injects a Web3 provider into the browser so that you can use it in the browser, a lot of people think that you can get, just like in MetaMask where you see all of your tokens, that you can, through the Web3 provider, get an array, for example, of all the tokens. But you can't. There is no function to get all tokens from address. You can't use Web3.js or Ethers.js to do that. What you would need to do, if you were to use those tools to try to accomplish this, is that you would need to query all of the different token contracts. So you would need to query one token contract at a time and ask it, okay, what's the balance of this address? And you would take the address from MetaMask, you would query, okay, balance off for this contract, balance off for this contract, balance off for this contract. You would have to do that thousands and thousands and thousands of times for all of the tokens in the world in order to figure out what tokens this address actually owns. And that's of course not what Syrian does. If I refresh this, it's very quick to calculate exactly which tokens I have and the price and so on. And it doesn't only take what I own here on Ethereum, it also does it cross-chain. We'll talk more about that later on. And it checks how much I have on InstaDApp, Compound, all of this stuff. Here you have Compound governance, you have savings in Compound. So it does a lot. So how does it accomplish this if you can't do it with Web3.js? Well, what you would need is an actual Ethereum node that you have synced and where you've also indexed all the data that you want. So you have saved and indexed so that it's searchable the tokens that all of the addresses own. So you need to query through all of the entire blockchain data to find the different ERC20 contract and events that a specific address has interacted with, and then get the balance of function for all of that, but then you save it somewhere. So actually save a database with this information so that you then can query it easily for a specific address. So that requires a lot of space. It requires a lot of time because the sync and ETH node is very time consuming. Many people use other type of services for that. But you would still need some sort of database where you store this information. And that in that sense, you can get all the tokens. Well, in that way, you can get all of the tokens of a specific address. You need to have a full node. You need to index all of that data and then save it. So, okay, you might save a user profile for this address where you have, okay, here are their tokens. And then you can start to pull in price data and all of this stuff. But it's impossible to do with just the regular Ethereum APIs that you use in JavaScript. And then the other question is, okay, how do you do this with cross-chain stuff? So then you need other nodes. Then you need, in this case, Binance Smart Chain nodes, and you need the Polygon node. You need a lot of different things in order to come up with all of this stuff. You can't just do it with an Ethereum JavaScript API. So that is the limitation. And what specifically are the limitations? Here we've talked about token balances, but other limitations are, things like just NFTs, but that's also token balances, right? But if you haven't thought of it in that way, NFTs would be the same thing. What NFTs do you actually own? And, what do they look like? And then you have, transaction history. You can get that here as well. You can get history. That will also take a long time, especially if you have a long history. You wouldn't be able to do that through Web3.js or Ethers.js. The same thing goes with events. You can get some events through these tools, but if you want to get a lot of events from, all the way back in history from block zero, that's not going to work with these front-end tools. And also, if you want to do any sort of, aggregated calculation, maybe you want to do some statistical analysis on these, you want to filter on these, then you need to have them indexed, and you need to have them, run those calculations on the back end if you want to do statistics, aggregation, that type of thing. So really, if you want to do a really powerful app like this, or you want to do like Etherscan, like here, these also, obviously they have indexed all of this data in their database, where we can just quickly search for a specific address. We can get all of the transactions, we can get all of their balances. This is not just a dApp where you have a front end interacting with the Ethereum blockchain through MetaMask. That's not how this works. So real dApps are a little bit more complicated. They are not just a front end and a smart contract. They have a back end as well to help with all of these calculations, to help with all of this indexing. So as a developer, you're watching this. What's the easiest way for you to get this infrastructure going without having to pay a fortune? Well, one route that you can go is, of course, to do everything yourself. You can get your own node, sync it. It takes everything from a few weeks to maybe a month, depending on your connection. You need more than a terabyte of space. Then you need to index that, so you need different type of historical nodes, and you need different type of indexing tools. And then you also need to build an API for that, so that you can easily query all of this data. You might need some sort of user management, or you want to save data for different users so that it's easily accessible. And then if you want to support cross-chain, you need to do the same thing with Binance Smart Chain or with Polygon, some sort of second layer. You need to do the same thing for that. And 99.99% of devs will not do that. They will not run their own full Ethereum nodes and so on. What a lot of people will do is use APIs like Infura, for example. Infura powers the entire Ethereum ecosystem, basically. So people will buy a subscription on Infura. They will pay for their APIs and pay for they are running nodes, and then you pay them in order to access those nodes and to get the data. And there are other Ethereum APIs like that you can use in order to retrieve data to your backend and then display it in your dApp. So you can use that. So you still need your own backend, but then you can get the data from the Ethereum blockchain without having to run your own node and index all of that data. The solution that I would recommend is, of course, to use Moralis, and that's why this video is on this channel, because with Moralis, you get all of this with a one-click setup. You get your database, you get all of the nodes that you need, both for Ethereum, for mainnet, for testnet. You get Binance Smart Chain, you get Polygon, and we're adding more, basically every single week. So you get all of the different chains that you need. It's cross-chain, you get user management, you get token balances, token transfers, transactions, events, everything that you need. And currently it's free. I mean, I don't know if it's free when you're watching this, but currently Moralis is free. And you get everything in a nice user interface. So you don't even need to build your own backend, build your own API. You can just know your front-end stuff and your Solidity stuff, and then you can build powerful apps like this. There are no limitations to what you can do with Moralis. You can build powerful apps like this. You can build powerful apps like this. You can build marketplaces, as you've seen on this YouTube channel, with a tool like Moralis. And everything just requires one click to set it up and integrate Moralis into your web page. And that's about it. And you can check out all of the different tutorials on our YouTube page to figure out exactly how it works. But now you know sort of the limitations that exist with just having a front end with Web3.js and a smart contract, and what you need to do in order to get the full power of the Ethereum blockchain into your dApp. So check out moralis.io, check out our hackathon, moralis.io/hackathon, subscribe to the channel, hit the like button, and I'll see you in the next video.